Welcome to video 5,
where we'll be learning about servos.
Before we begin, here are the materials you will need. An adapter, a micro USB cable, the microbit, a servo, and the DF driver board.
What is a servo? Well, here's the definition, and it's short. A servo is a small motor that moves to an exact angle and holds there.
At 0 degrees, the arm points left. At 90, it's straight up. At 180, it points right.
Now here's the part that matters. You give it a number, it goes to that number, and then it holds. It doesn't drift or keep going, it arrives and it stays, unless of course it's in a loop.
One thing to get straight before we go any further, because almost everybody gets this backwards the first time.
When you say 180, that does not always mean turn half a circle. It's not an instruction to rotate by 180 degrees, it's an address.
Think of it like house numbers on a street. 0 is one end of the street, 180 is the other end, 90 is the house in the middle.
When you say 180, you're not saying drive 180 houses further. You're saying go to number 180, and where the servo travels from depends entirely on where it already was.
So if it's sitting at 0 and you say 180, it swings all the way across. If it's sitting at 170 and you say 180, it barely twitches. Same command, completely different amount of movement.
And if it's already at 180 and you say 180 again, it does nothing at all. It's already there. Now the comparison between a servo and a motor.
A servo moves to an angle. It holds when it arrives. Its whole world is 0 to 180 degrees.
A motor spins continuously. It never stops on its own. You have to tell it to stop. And you don't give it an angle at all. You give it a speed, 0 to 255.
So look at what each one is for. Servos, steering, robot arms, gates, all things that need to point.
Motors are for wheels, fans, conveyor belts, all things that go round and round.
So to sum it up, a servo points and a motor spins.
Before we start, the servo and motor code are both part of a make code extension, so go ahead and paste the link found in the handout and description box.
All you need is one block. Servo, S1, degree, 0.
Make sure everything's connected. Here's the demo of us doing it.
S1 is the port your servo is plugged into. If yours is an S2, change that drop down. And the number at the end is the angle you want, anywhere from 0 to 180.
Now let's use this block. But first, we'll use the forever loop. This ensures that everything inside runs continuously because, as mentioned before, unlike motors, servos are not continuous.
Let's first get the servo to move from 0 to 90 to 180 and back to 0. Go into the DF driver extension that you just added and you'll see the servo S1 degree 0 block. Drag that in.
Now from basic, add a pause and set it to 500. That's half a second. Code is instant. The servo is a real object that has to physically swing across, so if you don't wait, the next command shows up before it's even finished moving.
Now do it again at 90. The same two blocks. Servo S1 degree 90 this time. That's the middle. Then pause, 500.
Now do it again at 180. The same two blocks, one more time. Servo S1 degree 180 this time, the far end. Then pause 500.
Don't skip that last pause. Without it, the servo reaches 180 and the loop yanks it straight back to 0, so you never see it stop there. Now hit download and watch your servo move.
Now let's try another scenario where we have the servo start at 0, go to 90, then 180, and then on the way back, have it stop at 90 before going back to 0, and have it loop over with the forever loop.
We're done the first half of the scenario, now let's do the other half. Add 2 more blocks to the bottom of the loop. Servo S1 degree 90, then pause 500.
And 1 more. Servo S1 degree 0 and stop there. No pause after that one because we're back at the start.
Download it again and see it run. Now it's your turn. Play around with the servo, change some of the numbers, and see what happens. Experiment and have fun with it.